Let me walk you through exactly how scientific research gets distorted as it travels from peer-reviewed journals to your Facebook feed, because understanding this process is essential for not being misled. Every step in the chain introduces distortion, and by the time research reaches general audiences, it often bears little resemblance to the original findings. It starts with the researchers themselves, who appropriately use cautious, hedged language in their papers. They might write something like, "Our findings suggest a possible association that warrants further investigation," or "These preliminary results indicate a potential signal requiring validation in larger populations." This is responsible scientific communication, acknowledging limitations and avoiding overconfident claims. Then the university press office gets involved. They need to promote their researchers' work and attract media attention, so they issue a press release that takes those cautious findings and sexes them up a bit. The hedging starts to disappear. Warrants investigation becomes raises questions or highlights concerns. Next, journalists cover the story. Most health journalists lack deep scientific background and face intense time pressure. They might not read the original research, relying instead on the press release. They need an attention-grabbing headline that will generate clicks in a crowded information environment. So, preliminary findings suggest possible association becomes new study links vaccines to health concerns. Then social media takes over. People share articles based on headlines alone, without reading the content. Each share adds commentary that further strips away nuance. By the time something has gone viral, the original study's careful qualifications have completely disappeared, replaced by confident claims of causation that the researchers themselves never made. Let me give you the concrete example we've been discussing. The OncoTarget paper was a scoping review of case reports suggesting that vaccine-related lymph node changes might, in rare circumstances, warrant closer clinical attention. It explicitly called for further research and investigation. But as it spread online, it became proof that vaccines cause cancer, a claim nowhere present in the actual paper. There are structural incentives driving this distortion. Media companies profit from engagement, and fear and outrage generate far more clicks and shares than nuanced scientific discussion. Journalists face relentless pressure to publish quickly, leaving little time for careful analysis or consulting independent experts. And corrections never achieve anything close to the original story's reach, so there's minimal accountability for misrepresentation. Here's how to protect yourself from this distortion chain. First, always try to find and read the original research, not just articles about it. Look for whether the journalist consulted independent experts who weren't involved in the research. Pay close attention to hedging language like may, could, suggests, and associated with rather than definitive language like causes or proves. Check whether the headline actually matches the article content and whether the article content actually matches the research findings. You'd be surprised how often there's a game of telephone where each step introduces more distortion. Be especially skeptical of research that gets covered because it contradicts established scientific consensus. Ask yourself, is this a single small study challenging a large body of evidence? That's not necessarily wrong, but it should be treated with appropriate skepticism until replicated and validated. Watch for the classic distortion pattern where research finding no strong evidence of harm but appropriately calling for ongoing monitoring gets headlined as questions raised about safety. It's technically true but deeply misleading, confusing normal scientific process with evidence of danger.